Hey everybody, I'm going to try this Screencastify. I'm just going to make a short video with a quick review, and then I'm going to have you watch it to make sure that you can see it. So I've got the notebook here under the document camera, and this is what we've done so far these past few days that you have been here. We have learned different exponent properties and how to simplify expressions using those properties. For example, multiplying powers, like 2x squared times 3x squared. These are both powers. The 2 and the 3 are your coefficients, and your little powers are the x squared, x squared. So when you have coefficients, you still multiply them, because this is a multiplication problem. You multiply the coefficients. 2 times 3 is 6. And remember, the quick rule we've learned is that when you are multiplying powers, if the bases are the same, which they are, we have an x and an x, you can just add the exponents together. So this will be 6x to the 4th. Now, what you don't want to get this confused with is if you have something like 5 to the 3rd times 5 to the 2nd, because these 5s kind of look similar to the 2 and the 3, but the 5s are the base to these powers. So you wouldn't multiply 5 times 5, just like up here, the x stayed x. Here the 5s stay the same, and because they are the same thing, you just add your exponents. So this would be 5 to the 5th power. So multiplying powers. And even if you have multiple variables, like a squared b cubed times a to the 4th b squared, you would take care of your a's and add those exponents. That would be a to the 6th, and then do the b's. That would be b to the 5th. And if they did have coefficients, if you had a 5 here and a 2 here, then that would just be 10 a to the 6th, b to the 5th. Okay, so that's multiplying powers. Multiplying powers. We have raised powers to powers. For example, if you have x squared and we want to raise it to the 3rd power, the rule here is that you multiply your exponents, so that would be x to the 6th. If you have a coefficient in front of these, like 3x to the 3rd to the 3rd power, a lot of 3's there, everything in here is being raised to the 3rd power. So 3 to the 3rd power is 27, and then x cubed, or x to the 3rd power to the 3rd power, we multiply those exponents, so that would be x to the 9th. This 3 and that 3, this coefficient and this exponent is no different than saying 3 to the 3rd power. It's 27. Okay? And again, if you have multiple variables, x squared, y cubed, all of this to the 3rd power, 2 to the 3rd power is 8. Then you multiply your exponents for each base here. For the x, you would do 2 times 3, that'd be to the 6th. For the y, you would do 3 times 3, which is 9. Okay, and that's raising powers to powers. Put that in its own little section there. Multiplying powers, raise power to a power. We have divided powers. For example, x to the 7th over x to the 3rd. Your rule here is if the bases are the same, you can subtract your exponents. So x to the 4th is what that would be. If you put a coefficient with them, 10a to the 5th over 2a to the 3rd, then you divide 10 divided by 2, which is 5, and subtract the exponents of your powers because the bases are the same. So that'd be a squared, 5a squared. We have talked about the zero property. Anything to the 0 power is 1. I know that's weird. It looks like it would either be, if you have 3 to the 0 power, some people think, oh, that's 0, but it's not. Or some people might think, oh, that's 3, but